Hi everyone, welcome back. This video is part of a playlist on Azure Machine Learning Studio and Azure AI Studio networking. Today we are going to specifically talk about ML Studio and networking. We will start with public access option, and over the course of the next few videos, we will dive into managed VNet and BYO, bring your own VNet as well. Of course, public option is only recommended for labs and dev test workloads. But today we will start with public and we'll work our way up to the other options, other more secured options. We will train a regression model later as an example for completeness. However, the focus of this video is more on the networking parts. So let's dive in. What you see on my screen should look familiar to you by now. We start with a hybrid cloud architecture with an on-prem at the bottom and the blue box being Azure. And we will also introduce the concept here for customers, PaaS. So imagine that the customer does have some existing PaaS solution. And then we will look at the machine will deploy the machine learning workspace, and we will deploy the machine learning workspace with the public option. So as you can see over here, when we deploy it, we will choose the public option. Okay, so that's at a high level what we're going to do today. And let me show you what happens when we kick off the machine, when we build a machine learning workspace. Behind the scene, it not only provisions the workspace, but it also provisions a bunch of PaaS services. So I'll show you all of that first. We will kick off the machine learning space build out using VS Code, and then I will show this to you in the portal as well. So let's jump into VS Code and kick off the build out. So first we'll verify that we are indeed connected, and just so you can see how my screen is laid out over here. I know it's a dark screen. So the top half is all the commands that I will run, and the bottom half is where when I run the command, they would get reflected at the bottom. Okay, so let's go ahead and verify that we are indeed logged in. So it's just a quick query. There are a bunch of resource groups created already, but what we will do is we will create a resource group with the prefix demo. Okay, so in here there is no demo, so everything we'll work on today will be with demo. So I set the prefix, and I'll set the location. Based on that prefix, we'll create the resource group name and the workspace name, and we'll echo the resource group. If you want, we can also echo the workspace name so that we can see that it also has demo appended to it. So now that we have all of our variables set, let's create the resource group. The source group is created. We'll create the container registry. We're only going to create the container registry. The rest of the um, PaaS services will get created automatically. And this is the command to create the machine learning workspace. The main option from a networking perspective is we're going to say public network access enabled. In other words, PNA flag is enabled. So let's go ahead and kick off the workspace build out. So while the workspace is building, let me show this to you in the portal as well. So if you are in the machine learning, so you can just search for Azure Machine Learning and you will land up over here. So when you create a new workspace, this is exactly what we did through the command line, but I want to show this to you in the portal. You will see that in addition to resource group and name, it also asks you for these four PaaS services: storage account, key vault, app insight, and container registry. All right, these become more relevant when we start to use private endpoints, but for today's video, these are all publicly accessible. And then if you go to the networking tab, again, today we are going to choose the public. This again is used more for labs, and for enterprise workloads, we'll have a deep dive video on these two options as well. And these use managed VNet. Okay. So let's go back and see if our workspace is being provisioned. Yes, so our workspace is provisioned. So let's look at it, how it looks, how the resource group looks now. So if I go back into resource group, let's refresh this, and there our demo resource group is created. If I look at the resource group, you'll see all of those past services that I mentioned about. Okay, so the easiest way to launch the studio is you can go in here in this either you can go it from the resource group, or you can go from the machine learning. If you refresh the screen, you can launch the studio from here as well. So click that, and then we can launch the studio. So now that we have the studio launched, we are going to use, this is what a typical data scientist would do, is we'll go to one of these tabs, and today we're going to use automated machine learning just as an example. So what we'll do is we'll train a regression model using AutoML. Okay. But before we could do anything, we need a place to run our workloads. In other words, we need a compute. So let's go ahead and kick off the compute instance build out, because it takes some time. So let's go and call this demo, right? And so we'll call this demo, we'll pick one of these, and we'll just keep it on for a couple hours. And I'll show you the places where the network integration happens. For today's build out, we are not going to integrate it with any network, but this is where in the future we'll do BYO VNet or managed VNet, is where that integration happens. Okay, so today's scenario is very simple. And so let's go ahead and kick off the build out. And we'll create the compute. So this will take some time to finish. So let's jump in the draw.io, and I'll explain the overall flows. Let me make sure you can see everything. Yeah, so far what we did was we went in and using VS Code, we used this command. The command's also shown over here. And if you were to do it in the portal, the corresponding experience in the portal is over here. And so what we did is when we kicked off the workspace, behind the scene, it provisioned all of these default PaaS services, and it also created a machine learning workspace. So how would someone access this machine learning workspace? In a public option, in the public network options, it's very simple. This user, so let's look at all of the flows. This user out on the internet can access this machine learning workspace directly, of course, through the Azure credentials. And this user sitting, let's say if there is if you're running some program through a Python or something, you can still access it using the public access. And remember that all of these PaaS services with the public network access, anyone from the internet can, of course, access that. And how will the on-prem user access it? Let's look at that flow. On-prem user of course, is also going to access it through the internet. Notice it's not going over the private express route connectivity over here. It's not going through that. It's also accessing it over the on-prem. Again, this will all fit in much better when we do other network option. Remember, this is the simplest option, public network option. So we will, so those are the different flows that we can see. And next, what we just did is we spun up a compute, what we call the batch compute. And once the compute is done provisioning, we will kick off an auto ML job. So let's take a quick peek at how our compute looks like. So compute is still creating. So let's go back in Draw.io and I'll explain a few more concepts here. So once the compute is done provisioning, we'll kick off an auto ML job. Now, what is an auto ML job? Again, the focus of this is networking, but for completeness, I'll do a quick review of what an auto ML job will do. So what we'll do is we'll start with, let me have my mouse here and we'll use the green color. We'll start with, we'll create a data set. So I have a bike rental data set, which is publicly available from the Azure websites, GitHub websites. And then we will train the model. And then we'll evaluate the model, and then we will deploy it as a public endpoint. So think of an endpoint as a publicly accessible URL, right, which is used for inferencing. So with that, let me show you how that flow will look like. So once the batch compute is done, we will go through all of the steps that I showed you before, and then we will deploy, as the last part, we will deploy this machine learning, we'll deploy this endpoint. Now, if you see this endpoint, let me just zoom in a little bit here. It has this URL, which is inference.azure.com. Okay, and so then you can query it, you can send a request. So this is a very classic inferencing example. I have taken it off of the Azure Learn website. So there is a link to that, and I'll show you all of those links in the portal as well. I mean, in the browser as well. But essentially, this user will make a request to this endpoint, and it will come back with a response. So in our example, we're going to use a bike rental database, and we're going to predict the number of bike rentals on that particular day. So let's go back, and I want to show you, we'll quickly check our compute creation, which does take time. So we'll refresh this and looks like it is running. So let's go ahead and use this. Let's double check that it is indeed running. Great, so it is running. So let's go ahead and kick off the auto ML job, because that one takes time as well. Again, we will use this auto ML job. We'll first create a data set using a CSV file, and then we'll train a regression model and then deploy it as an endpoint. So that's the full process we're going to go through. So here you could see, let me first show you a couple different things in the browser here. So this is the CSV file, GitHub content.com. The link is below. So this is the CSV file that we're going to use to train our model. So let's kick off the new automated machine learning job. And we'll go with the defaults. Like I said, the focus here is more on networking. So we'll go ahead and we'll select the type as regression to predict the numeric values of the bike rentals. And then we'll create a data set. Let's call this data set bike rentals. And then we'll choose the type as tabular. If we choose the type as tabular, we get the option to pick from web files, and that's where we will put this URL for the, we'll put this web URL. This is where the CSV file is. And we'll go through this. It should load there. It has loaded the CSV file here. And these are all the features. There's a lot of tweaking you could do over here, but for the purpose of this exercise, we'll just go ahead and hit create over here. So now that we have our data set, we will then move on to the next task. So we'll pick the bike rentals database data set. And then here we have to pick a target column. Target column is the rentals. That's the value, that the numerical value that it's going to predict. And here, just be sure to set the timeout to be 15 and 15 over here and enable early termination. This is just so that it doesn't run forever. Now, I do have a link that I have put in to the exact same process that we're going through. And this is off of our fundamentals of machine learning. And if you go into explore automated machine learning and launch exercise, this is the exact same process that I'm going through right now. All the details, and it also talks about the bike rental database. So let's go ahead and hit next here. Let me make sure I didn't miss anything here. Okay, perfect. And here we get the option to pick the compute, and there we have our demo compute up and running, and we can kick off submit our training job. This does take time, so if it doesn't finish, I do have a completed job that we can use, but let's go ahead and kick off this training job. So coming back over here, I want to show you some of these tabs that I have open. So here, the most important from a network perspective in machine learning, there is documentation on managed virtual network isolation. So for today, we're not using isolation, but this is where all of the networking bits get configured. Then this is the Azure machine learning automated machine learning in Azure. This is that exercise that we just did. And then this is the content, the bike rental database, and this talks about inferencing and endpoints. So all of these links are below, but just so you have this. So let's go ahead and just double check. Yeah, so while this is running, let me just make sure I can show you all of I've shown you all of the flows. Yeah, so right now we have just kicked off the machine learning job, and the last part is creating the managed online endpoint so that we can do inferencing with it. So given this is taking a little bit of time, let me show you how you can create, let me show you a completed job, and then we can walk through the endpoint creation. So if you see over here, let's refresh this. In here, this is the job that we just created, and it is still, if you go over here, the status over here is still progressing. So what we will do is we'll go to a workspace that I already have created. So remember, this demo is the one that we just kicked off, but in the interest of time, I already have another workspace. So let's go in there. and I'll show you a completed AutoML job. So here you see the status that shows completed here, and so that's what you have to wait for in the other job. So now that the status is completed, we can make a few observations. So what you see over here is that you have a the best model summary. And once you see this, all of this populated, you can also see that there is this normalized root mean squared error. Of course, this training is not about machine learning, but this is what tells how good the model is. The lower the value, the better it is. And then you can view all of the metrics if you wanted to. Okay, so this is nothing but this normalized root mean square error is nothing but the difference between the predicted value and the actual value. Of course, the lower the value, more accurate the model is. So we're going to go into the voting ensemble model, and then we can go ahead and deploy a real-time endpoint. Okay, so I'll walk you through how that experience looks like. It's very easy. You just deploy, and like I said, there are a few different options. We're going to pick the real-time endpoint option, and it will then deploy a real-time endpoint. As you could see, this URL, this is your inferencing URL that gets generated after the endpoint is created. And so what you do is you go ahead and then you click this, this deploy button. Okay. So I've already created the endpoints over here. And I'll walk you through what happens after the endpoint is created. So let's take a closer look at this endpoint. This endpoint, first off, you have to make sure that it is provisioning state succeeded, and you can see the REST endpoint over here. And interestingly, it also allows you to run the test here through the portal, and then you can consume it through your Python or any of your SDKs. You can consume it. So let's just do a first test with some data to see if we can connect to the endpoint. So the easiest test to do is through the portal. So what I'll do is I'll populate this with some values, and I'll put this in the link. I'll put this on my GitHub repo, so you have it. So I just gave it some data, and then if when you hit test, it will predict the number of bike rentals. So there, this is all working. So let's figure out how to do this more programmatically. So to do this programmatically, what I have done is instead of using Python or C, I'm using, you could use Postman, I'm using straight up curl. So what I did is there are three values over here that are important. So let me show you those three values. This the REST endpoint, the key, and the third point is, you can see it somewhere here. Let's find it. Yes, this is the model that you want to also reference in the curl command. Okay, so let's go back to the curl command. I've already staged that command. So we'll go back in here. And of course, I'm going to delete this workspace so I see you can see my key. But so these are the three variables that you can set. And notice this inference URL, which I just grabbed. and then we will set the data. So this is how you can call it more programmatically, and then we'll run a curl command. And there it has also predicted the value over here. So this is working through the curl command and also working in the portal. So let's go back in the portal. So this was through the portal. Now, the most important thing from a network perspective and the flow perspective, and this is everything will become more relevant as we dive into more complex scenarios or more secured scenario, I should say, more enterprise type scenarios, is that this managed endpoint today is reachable through a publicly reachable endpoint, and then you can also make that private. All right, so let's take a quick look look at our machine learning job that we create, the automated ML job that we created. Again, to navigate, you go to workspaces. We'll go through to our demo, and then we'll go through this one, and let's go take a look. So this one is still going. So, but as I mentioned, once this is completed, and you will see the best model summary get populated over here. And from there onwards, the last step after this is to deploy the endpoint. And let me just show you one more place where you can validate. So here, let's go back to the public workspace. And after you kick off, so remember how we navigated, we went to AutoML, and then we went to the voting ensemble model, and then we did a deploy real-time endpoint. After we do the deploy real-time endpoint, it will show up over here, and that's the endpoint that we were using. So thanks again for joining me. I hope you enjoyed this session. Drop me a comment if you have any question or if you would like to see any other videos, and I will see you in the next video.